Jupiter, a world of mystery, power, and sheer scale. The largest planet in our solar system, a massive sphere of gas and swirling clouds that looms as a giant among the stars. Standing at over 86,000 miles across, Jupiter is so immense that you could fit more than 1,300 Earths inside it. Yet, despite its enormity, Jupiter holds many secrets beneath its gas-filled surface, secrets we are just beginning to uncover. The sheer vastness of the planet and its system of moons, more than 70 in total, raises an extraordinary question. Could we, as humans, ever live in the shadow of such a planet? Could we ever call Jupiter's domain home? As we venture into this question, we'll explore the science, the mysteries, and the future possibilities of humanity's existence near this gaseous giant. Let's start with the basics. What is Jupiter made of? Unlike Earth, which has a solid surface we can stand on, Jupiter is a gas giant, composed mostly of hydrogen and helium. Its atmosphere is thick with clouds of ammonia and methane, creating a beautiful yet hostile environment. Beneath these clouds, the pressure increases dramatically and temperatures drop to deadly lows. And while the atmosphere seems to offer an endless array of swirling colors and clouds, it's not the kind of place we could ever walk, breathe, or thrive on. There is no surface to touch, no solid ground on which to build a home. To even think of surviving on Jupiter itself would be impossible, but that doesn't mean we should dismiss its allure. Jupiter's atmosphere is a world of constant motion. Its famous Great Red Spot, a storm that has raged for at least 350 years, is just the most famous example of the planet's volatile weather. The clouds here, composed of toxic chemicals, are constantly swirling in bands, creating wind speeds that could tear apart anything we send near it. And then there's the radiation. Jupiter's magnetic field is so powerful, it traps harmful radiation, bombarding the planet and anything near it with deadly intensity. The storm systems here have been known to produce winds up to 400 miles per hour, strong enough to rip apart entire spacecrafts and anything in their path. With such extreme conditions, it becomes clear that Jupiter's surface is not the ideal candidate for human settlement. But that doesn't mean there aren't possibilities elsewhere in the Jovian system. As we look beyond Jupiter's cloud-covered surface, we realize that the real possibilities for exploration lie in the very moons that orbit this immense planet. Jupiter's moons are not merely satellites. They are worlds unto themselves, each unique, each holding its own set of mysteries. And it's here, in the shadow of this massive planet, that humanity may one day find a place to live and work. What's truly fascinating is that while Jupiter itself may be inhospitable, the moons surrounding it could one day serve as stepping stones for exploration and perhaps even human colonization. It is not on Jupiter that we might find our future, but in its orbit, on its moons, and perhaps even in the vastness of space between them. The potential to live around Jupiter, even if not directly on it, may offer the next great chapter in humanity's quest to explore the cosmos. Take, for example, Europa. This frozen moon, smaller than Earth's moon, is covered in a thick layer of ice, beneath which scientists believe lies an enormous subsurface ocean. While the surface is icy and hostile, beneath that ice could be a hidden world, one where liquid water, essential for life, exists. Europa's ocean could harbor microbial life, a prospect that has captured the imagination of scientists for decades. It's one of the most promising places to search for life beyond Earth, and while humans could not live on Europa in the traditional sense, the prospect of establishing research bases beneath its icy surface is tantalizing. The cold temperatures on Europa reach near minus 260 degrees Fahrenheit, minus 160 degrees Celsius, far too cold for human survival without sophisticated technology. To explore Europa, we would need to protect ourselves from its frigid conditions, perhaps with advanced thermal protection systems, while also shielding against the radiation from Jupiter's magnetic field. But beneath this ice could be an entirely new world, a world that could potentially support life, or at least the resources we need to sustain ourselves. Europa's ice is a window to what lies beneath, a potentially vast ocean of liquid water. If life can survive in such extreme environments, Europa could hold the key to understanding how life might exist in similar conditions elsewhere in the universe. Could humans one day build underground cities, sheltered beneath Europa's icy surface, and tap into the resources that lie hidden in its ocean? The technology required to make that possible is still a dream, but it's a dream that draws us ever closer to the possibility of living beyond Earth. Imagine colonies of researchers, explorers, and scientists living beneath Europa's ice. Their work a testament to humanity's relentless drive to explore, to adapt, and to thrive in the most extreme environments. Then there's Ganymede, the largest moon in our solar system. A world that holds some surprising features of its own, such as a magnetic field that could protect its surface from the harsh radiation from Jupiter. The presence of water ice on its surface suggests that, like Europa, Ganymede could have a subsurface ocean. And while the surface temperatures here are frigid, around minus 370 degrees Fahrenheit, minus 223 degrees Celsius, Ganymede's magnetic field might offer a level of protection against the intense radiation that makes Europa's surface so dangerous. For future explorers, Ganymede could be a safer base of operations, one that offers a more stable environment than the constantly changing surface of Europa. But to live on Ganymede would still require us to harness and develop technologies that can help us survive in such an inhospitable climate. Callisto, another one of Jupiter's moons, stands out as one of the most stable of all the Jovian moons. Its surface is ancient, covered in craters from countless impacts over the ages. Unlike some of the more geologically active moons, Callisto is not subject to the same violent forces, making it a potential candidate for long-term human habitation. Its distance from Jupiter means it is largely shielded from its radiation, offering some safety to potential settlers. But like the other moons, the temperatures are bitterly cold, and any human presence would require advanced habitats with sophisticated life support systems. Callisto's relative stability and lack of volcanic or tectonic activity might make it a prime candidate for a human base, perhaps even the first outpost in the Jovian system. From Callisto, astronauts could study Jupiter's atmosphere, its moons, and its role in the solar system while remaining protected from the most extreme conditions. Another possibility lies in orbit around Jupiter itself. While living on the gas giant is impossible, the idea of establishing a space station in Jupiter's orbit has become an exciting prospect for space exploration. With the right technology and shielded from the radiation of Jupiter's magnetic field, these space stations could become thriving research hubs. These stations would be equipped with life support systems that could provide oxygen, food, and shelter while protecting inhabitants from the hazards of Jupiter's atmosphere and its surrounding radiation. By using advanced propulsion systems, humanity could create a permanent presence in orbit, conducting experiments and studies to better understand the giant planet and its mysteries. Technology is advancing at an extraordinary pace. From breakthroughs in artificial intelligence to new propulsion systems that can travel farther and faster than ever before, we are on the brink of an era where humanity will move beyond Earth's atmosphere to establish a presence on distant worlds. As we develop new materials, new life support systems, and techniques for surviving in extreme environments, the possibility of living in orbit around Jupiter, or even on its moons, becomes more real. With advancements in energy production, long-duration space travel, and autonomous systems, we may one day have the ability to build colonies that can survive in the harshest conditions. Jupiter, with all its dangers, could one day become the next frontier of human exploration, not as a place to set foot, but as a domain to study, to learn from, and perhaps even to thrive within. Jupiter's sheer magnitude is awe-inspiring. It stands as a giant among the planets, a silent sentinel at the center of the solar system, its immense gravitational pull influencing the very nature of the solar system itself. Could humans ever live on Jupiter? The answer, in a literal sense, is no. But could we live in its orbit or on its moons? Could we unlock the mysteries of this gas giant, harnessing its resources and studying its vast atmosphere? The answer, perhaps, is yes, though it will take time, technology, and an unwavering commitment to the spirit of discovery that defines us as humans.